All right, gang, Math 5130, following up on the last video demonstrating how to run a chi-square test of independence, which again analyzes the relationship between two categorical variables. So we're going to use the vaccination data set. So let me go get that. We used in the previous video. Pop it into StatCrunch, and we have it. So scroll down, got a rather relatively large sample of 214 subjects. So we want to generalize the sample to whatever population it was drawn from to see if there is a relationship between vaccination and sick. And again, remember, the null hypothesis is that vaccination status and sick status are not related. They are independent. The alternative hypothesis is vaccination status and sick status are dependent. They are related. So turns out it's super easy to do in StatCrunch. Just go to table and contingency with data. I think our rows in the previous video, I got complete transparency. We've been sick. COVID hit our house, so I haven't created since the previous video. It's been a while since I have done any work because I haven't really felt good. So anyway, but I think sick was on the row. I think vaccination status was on the column. So I'd probably want to include my expected cell count. This contribution to chi-square is kind of interesting. I'll tell you what, let's just pop it in there, and I'll tell you what that means. And you can easily get this through R as well. So we'd want the chi-square test of independence. Really not appropriate here because we have a 2x2 table. So again, for a 2x2 table, you either need to do a Yates, which actually isn't available in StatCrunch, which I find very interesting. It does the Fisher's exact test instead. So we'll find out that the p-value will be a little bit higher. Doesn't have quite the power of a generic chi-square test of independence. I'm not big. Those heat maps down here, if you want to click that, go for it, whatever. I don't think it does much. So if we hit compute in real life, well, no, in fake life, in this class, we would be focusing on those values. For example, for this cell, that's the observed cell count. This is the expected cell count, as this is the contributing factor for that cell to the chi-square test. So if I take 0.05, 0.04, 0.09, and 0.06, it will add up to my value, 0.23299. So again, we do not have statistical significance, so we can determine that the vaccination status and getting sick status are not related. Now, again, in practice, we would want to use a 2x2 test, so we'd report the Fisher's exact test or the Yates if we're working in R. And you can already tell that my preference is R. I'm not a big fan of StatCrunch. It's okay. It mirrors pretty closely SPSS, but you know, a lot of people just can't do R. They just can't pay attention to the detail of typing things exactly the way they have to be typed. So, you know, we all got our strengths and we all got our weaknesses. I know I do. All right, so let's get out of this, and I want to bring up. Let's see. Well, we really don't need to do that. So let me scoot over here, and let's talk about the difference between a summary table and a data set. So my data set is I have all the elements of for each case, like this particular person was not vaccinated, they did not get sick. 33, same thing. But sometimes we have a summary table. And the example that I'm going to use here, it's someone developed a screening test that they think will identify itchiness after receiving spinal morphine. So what happened here is apparently the subjects were given spinal morphine, then they were given a screen. These people were predicted to get pruritus. These people, according to the screening test, were predicted to not get pruritus. So what actually happened? 98 of those who were predicted to get pruritus did, 12 who were predicted to get it did not. 151 who were predicted not to get it actually did get it, and 663 who were predicted not to get pruritus did not get pruritus. So we want to see if this is if these categorical variables are related. Now, this is quite interesting. The way that we do this. Let me grab something. I got a lot of notes here. Well, yeah, I'll tell you what. Let's jump over into StatCrunch, and let me show you how we take care of this. So first thing I'd want to do is I would need to get a new session. Shoot. So, wow, I don't even know how to do that from there. Okay, let's just do this. Okay, so what I would do is I would set my variable name at pruritus and no pruritus, and then I would have screen positive. I think it'll allow me to do that, and screen negative. And what I would want to do is put in the values, type them in very carefully. And 663. Now you would think that we're probably going to get statistical significance because this is a really high count right here compared to the other cell counts. But again, we'll just let it play out and see what happens. So I'm going to go stat table contingency with summary. Now this is kind of weird, the way you have to do this, or at least I think it's kind of weird. We have to select both columns, but on the row label, we have to get just variable 1. It only allows us to select one of these, so we can't choose one of the screen positive, screen negative over the other. So I have to choose variable 1 to represent the variability in those two outcomes. So I would, again, like before, run these, and I want to run those two. So again, easy to run. So we do have statistical significance. Now, here's a situation where the contribution to the chi-square is very interesting. This contribution, 151, was much higher. So it seems that we have statistical significance because of the 98 who were predicted to get pruritus and did. The next highest contribution is this cell right here. So we have statistical significance. It would be reported degrees of freedom 1. Our chi-square statistic is 244.94, p less than 0.001. Same thing in R, works very nicely. I'm just going to create some variable, and I'm going to type the numbers, type the rows first. That's very important. So we get that. So the next thing I'm going to do is just create my table, and I do that with the matrix. So I want it to be X. I'm going to read it by row, which is true. My n rows is equal to 2, and my n columns is equal to 2. Okay, I knew that was going to happen. It's not n rows, it's n row. and this should be in column. All right, so then if I do chi-square test for my table, wow, I'm just really messing up today, aren't I? You can see that we get the same thing that we did before. Now this is with the Yates continuity correction, so if we're kind of concerned that the values didn't line up, match perfectly, remember we can just do correct equal false, and we get the standard chi-square test. But again, for the 2 by 2, you would want to report the Yates continuity correction. Now, I think on your MyStatLab assignment, I think you just report the value from the output in StatCrunch. All right, gang, that's all I got. That video was a little bit clumsy, but hey, it's good to have from time to time. Take care.